aviation accounts for a relatively small sliver of the total CO2 footprint globally, but there is not a solution today to decarbonize that sliver, and over the next 20, 30 years, we're expecting at least a doubling of the CO2 footprint, and you can't solve that problem by tackling international air travel, but you can solve it with small regional travel. Is it possible, using the technology that's available today, to decarbonize these short distance routes? And the answer is yes.
Hey folks, I'm Conor Gaughan, and welcome to Consensus in Conversation, a podcast where we're talking to the innovators, entrepreneurs, and thought leaders who are committed to building successful businesses that also help us build a better world. One of my favorite parts about making this show is how often I get to learn about new technology that genuinely blows my mind. Ideas so game-changing that they seem like science fiction. Something we actually talked about on a recent episode with Zal Bilamoria of Refactor. And speaking last week with my dear friend Ayanna Johnson about her new book, What If We Get It Right? Visions of Climate Futures, it occurred to me that many of these climate technologies that seem almost impossibly advanced to me today will one day, hopefully, be commonplace. That's actually the best case scenario. We want a world where renewable energy is so ubiquitous that it becomes boring to talk about. And that thought, in turn, got me thinking about how, in our modern world, we encounter an almost infinite number of inventions, technologies, and things each and every day that people hundreds of years ago would think of as science fiction. Or forget science fiction. Up until quite recently, people wouldn't have even had a concept of what it meant. Most of our ancestors would look at our modern devices like the iPhone and Bluetooth as nothing short of magic. After all, what's the famous Arthur C. Clarke line? Any sufficiently advanced technology is indistinguishable from magic. And yet, we take most of these things for granted in the day-to-day. I mean, how many times do you really think about what goes on behind the scenes to actually send an email, or FaceTime a friend on the opposite side of the world, or instantly call an Uber on our phone to our exact location? How often do we think about the miles of internet cables running across the bottom of our oceans when we connect on Wi-Fi? And it's not wrong that we take these modern marvels for granted. I know I do myself, and human beings are nothing if not adaptable. But it's worth occasionally stepping back to appreciate just how far innovation and technological development has come in the past century. But if there's one type of modern technology that will never quite lose its sense of magic and wonder to me, it's air travel, despite the many, many flights I've taken in the last month. It's impossible to not feel some level of awe when you're literally flying in the air, let alone when you travel across the entire United States in only a few hours. For thousands of years, the power to fly was among the most cherished and impossible of humanity's dreams. When the Wright brothers pioneered the first wave of aviation at the turn of the 20th century, few could have imagined just how significant the industry would be today. And yet, air travel really is still just getting started on a global level. Only about 20% of the world's population have actually flown on an airplane in their lives. What does all that mean? Well, for one, it means that there's still a massive untapped market around air travel. And as the market grows, so will air travel-related emissions. In fact, aviation's CO2 emissions are on track to triple by 2050, which makes sustainable innovation centered around aviation all the more important, and potentially hugely profitable. And this type of sustainable aviation is seeing both private and public investments. Take sustainable aviation fuels, which are renewable or waste-derived fuels that can reduce typical jet fuel emissions by up to 80%. The U.S. Federal Aviation Administration is providing grants of up to $50 million for sustainable aviation fuel development, and Brookfield Asset Management recently invested up to $1.1 billion towards synthetic sustainable aviation fuels. It's safe to say that sustainability and innovation in aerospace is taking off, pun intended. And who are the people actually leading the creation of these new fuels and planes? Well, to borrow a quote off a great contemporary artist whose work most beautifully celebrates the wonder of flight, airplanes are beautiful dreams. Engineers turn dreams into reality. And that's why I'm excited to be joined today on Consensus in Conversation by Ben Stabler, the Chief Technology Officer of Heart Aerospace. The company, founded in 2019, has raised more than $140 million from leading VCs and other investors for its mission to decarbonize and democratize air travel for all. Ben received his MS in electrical engineering from Stanford University, led hardware and software teams at SpaceX's Crew Dragon program, and co-founded an automated battery electric freight rail vehicle startup called Parallel Systems before joining Heart Aerospace earlier this year. Now, Ben is responsible for developing the firm's technology strategy and leading the technical team as it works to build a new era of electric planes. And yes, that includes the design of Heart Aerospace's core value proposition, its hybrid battery electric aircraft prototype called the ES-30. But instead of hearing me attempt to explain how it works and why it's so groundbreaking for the future of sustainable aviation, let's hear from Ben himself. But before we start, one quick programming note for you all. Consensus and Conversation will be off next week ahead of the Indigenous Peoples Day holiday weekend, but we'll be back to our usual schedule starting October 17th. Okay, let's dive into the conversation. Thanks for being here today, Ben. Super excited to have you and learn about Heart and get your background. Let's just start at the beginning. Tell us a little bit about yourself. Where are you from originally?
So I am originally from California, but I spent the first 18 years of my life in the UK. So I was born in the Bay Area in California. My parents moved to Sussex in the UK. And so I grew up there. And then I came back out here to California for college. I've been here ever since.
Yep. Like many, I think, young kids, did you always have a fascination with airplanes?
Oh, yeah, absolutely. Yeah. My wife, her favorite book is this book that I wrote when I was 4 or 5, talking about building an airplane. And every time we go home, she loves to pull that out and read through it.
That's awesome.
She gets a kick out of it.
Do you remember what it was that sparked that interest? Or like, was there a moment or an experience that stands out where you can first recollect that passion?
Well, I think it's just such an incredible sort of romantic idea that we can build a machine and then use that machine to fly through the sky. I think everyone is attracted to that in some way. And as I sort of became an engineer and learned more about the engineering and the science that goes into it, it just becomes more and more interesting. So you learn about how all these systems have to work together and the physics behind it. And, you know, around every corner, there's something that seems impossible. And then you sort of learn how it works and how sort of humans have figured it out. And it's, you know, we can talk about standing on the shoulders of giants. And I think aviation is one of those fields where, you know, giants abound.
Yeah.
So, you know, there's the sort of visceral, romantic part of it, but there's also the deep technical underpinnings as well, which, you know, both of them are exciting in their own way.
Yeah. Did you know when you were looking to head off to college that you wanted to work in this industry?
Well, no. So, you know, when I grew up in the UK, in that period, it wasn't obvious to me what an engineer was when I was in high school, or, you know, the equivalent. And that wasn't a sort of a field that a lot of people talked about at that age. And so when I came to the US, you know, my eyes were opened and, you know, it was a very natural place for me because I always enjoyed building things and understanding how things work and, you know, writing code and designing parts. And so, you know, very much just fell into that at college. So no, it wasn't something that I sort of knew I wanted to do and knew I wanted to be a part of. But as I got deeper and deeper, it became the realization that it was my passion.
Yeah. I mean, it won't surprise you, but we've had a handful of Stanford engineering grads on the show. And there seems to be something very special about the program that doesn't just create great engineers, but also builds the capacity for those folks to think entrepreneurially and pursue kind of business leadership. And I'm curious, you know, what you thought about your time at Stanford in the engineering department, and if you have kind of thoughts on what it is about that educational experience that produces leaders at such a comparatively high rate.
Oh yeah, it was incredible. You know, I think that the biggest part of it is just this belief that everything is possible. You go to Stanford and you're surrounded by, you know, really smart people and also success stories. Everywhere you look in the Bay, there's companies building things that people didn't think were possible. And I think that's a huge part of it. And so when I was at Stanford, I was involved with the Solar Car Project, which is a student-run project team that builds a battery electric, solar-powered vehicle and takes it, you know, to Australia and various other locations to race it. And that was a really key part of the formative experience as well. So, you know, on the one hand, you had all these startups around that were doing these incredible things. On the other hand, being part of this project where it was incredibly hands-on, fully student-run, no faculty involvement, and you're, you know, part of a really quite large engineering project where you're building all these different components, putting them together, working with the team, and really learning all of those skills that are required to actually go do some of these big things. That was a huge part for me. And so the balance between, you know, expansion of horizons in terms of what's possible, direct experience learning the skills. And then also obviously the academics as well, being in classrooms where you're, learning from the best professors in the world. The three of those really come together and set you up pretty well to go be part of a startup when you graduate.
Yeah. I mean, which also leads me to the proximity to Silicon Valley, right? There's so many startups to go look towards when you graduate. I'm curious when you were looking at graduation, like what was your search like? What were you thinking about? Where were you hoping to find yourself?
So I actually, and I think this happens to many people who go to Stanford, I got pulled into a few startups while I was still at Stanford. So I was working sort of part-time with some early stage companies. So one of them was my first summer, it was with this company, Mission Motors, which was building a battery electric motorcycle, kind of in the early days of Tesla. This was before the Model S had been released. So trying to sort of apply the same idea to motorbikes. And it was an incredible high performance machine. And then later on, I worked for a company called Wheels, which became part of Relay Rides, which became Turo. And so that company was, looking at sort of the democratization of personal transportation. So the idea of, you can rent your car out to someone else and they can use your car, and, this asset that is idle for 23 out of 24 hours of the day can be sort of shared, and, that can reduce the cost and improve the accessibility to people as well. So a couple startups like this, Renovo was another one that I worked with a little bit. They were building a battery electric supercar at the time. And you can kind of see a trend here. Like a lot of these came out of solar car, building battery electric vehicles. It was something that was really exciting to me. So I did both my undergrad and my master's at Stanford as part of a program they call the COTEM. So I graduated, and at the time it was the most exciting work that was happening in engineering was what SpaceX was doing. And so SpaceX was trying to land the booster.
Right.
And, SpaceX wasn't launching nearly as much as they are today. So it was every, 4 months, 6 months, there would be a launch and everyone would watch the video. Is the booster going to land? What's going to happen?
Yeah.
And so that was just so exciting. And I think everyone wanted to work at SpaceX at that time. And I wanted to work at SpaceX. So I found a connection and I came down to LA and worked at SpaceX. And I was working on the power systems for the Dragon was my main focus initially. And that was the first, so I joined in March. And then the first successful landing was in December of that year. So really, really good time to join the company.
That's awesome.
Yeah.
And it's interesting. I think there's a lot of parallels to Heart, which I want to dig into. I guess first is, SpaceX really disrupted the established kind of spaceflight aerospace sector. I think what Heart's trying to do is also fairly disruptive to aviation. So I'm curious kind of how you think about that as a parallel.
Right. So, both are aerospace companies, very different sides of the aerospace spectrum. So SpaceX building launch vehicles, building crewed capsules, and looking to the future to Mars. Heart building hybrid battery electric aircraft for commercial aviation. And in both cases, entering an industry which has, a rich, storied history, but which is in a little bit of a slump today. Mm-hmm. So when SpaceX entered the launch industry, there were not very many launch providers and not very many launches per year.
Right.
And obviously today you look at the industry and there's many, small launch vehicle providers. There's people like Blue Origin, people like ABL, Rocket Lab, Relativity, lots of companies building new rockets and, trying to grow the industry there. In aviation, very few new commercial aircraft in design right now. We hear from some of the big players that there will not be a new clean sheet design this decade, and, relatively slow adoption of new technologies like hydrogen, like SAF. And at the same time, the demand for aircraft is never been higher. So, huge demand for narrow-body aircraft, huge demand for both smaller and larger aircraft. Some of that coming off of COVID, but also generally, structural demand coming from, India and other countries coming online, and also the aging fleet. So you have to kind of ask yourself the question, why do you have this sort of juxtaposition of huge demand, never seen before demand, but also sort of a stagnation of the technology and a stagnation of the development of aircraft? And I think that what you saw with SpaceX, what you saw with the space industry is that it comes from this idea that designing new space vehicles is incredibly difficult, incredibly expensive, and therefore there isn't a business case to do so. But SpaceX kind of proved that that isn't really the case.
Right.
So the Falcon 9 development program, is a tenth the cost of the SLS development program, or less, considerably less, I guess.
Yeah.
You may have to do some fact checking on that last bit, but
We'll figure it out.
So you have an industry where the talent that designed the previous generation of spacecraft, the previous generation of aircraft, are no longer actively pursuing engineering design. So there's a knowledge gap, and that contributes to the cost. And if you can build the excitement like SpaceX did and get a new generation of engineers involved and take a new approach to how you do the engineering and take a much more modern approach, then you can build these vehicles, for much cheaper than anyone expected you could,
Right.
and really revitalize the industry that way. That was a pretty long answer.
No, but it's a good segue to, because I think you're setting up a good parallel to the origin story for Heart. So let's jump into that. Tell us a little bit about how Heart Aerospace got started, but then also kind of, your journey to how you ended up joining as CTO.
Right. So Heart Aerospace, really the vision here is let's decarbonize and democratize aviation. So aviation accounts for a relatively small sliver of the total CO2 footprint globally, but there is not a solution today to decarbonize that sliver. And as you look at the projections for how air travel is going to grow over the next 20, 30 years, we're expecting at least a doubling of the CO2 footprint as a result of, India and other countries coming online. There's 6 billion people who have never been on an aircraft before. And so, this is going to drive the carbon footprint of aviation up.
Right.
And there is not a clear solution to reduce that carbon footprint without increasing costs or restricting people's access to air travel. And so that was the genesis for Heart. How do we solve that problem? And you can't solve that problem by tackling international air travel. That's a part of the industry the science is not there yet to solve that. But you can solve it with small regional travel, which makes up a sizable chunk of the total miles flown. And so Heart, when Anders and Clara started Heart, it was to answer the question, is it possible using the technology that's available today to decarbonize these short distance routes, the kind of routes that you see in Scandinavia, in Europe, and the routes that connect communities that have the least access to air travel? So that's the democratization part of the story. And the answer is yes. The battery technology exists today to build a battery electric hybrid aircraft like the ES-30. You don't need an advance in battery technology to achieve that. And it achieves the performance that is necessary to run these short distance routes and connect these communities. And so that's what we're doing as a company now, and kind of the foothold as we look towards a broader decarbonization of the aviation industry.
And then what was your pathway?
Yeah, so I joined Heart just a few months ago. So I'm the CTO here in Los Angeles as part of our expansion into Los Angeles. And so we've talked about how sort of my interest in aviation goes back to when I was very young. I think most engineers are really excited about planes, and I'm no exception to that. I've been, excited about electrification since I was on the solar car project at Stanford. So, most of my roles, since leaving Stanford have involved electrification in some kind with, obviously SpaceX is not trying to build electric rockets, but there was a number of electrification projects within that. And so there's kind of this confluence of these two areas of deep interest. I also recently became a private pilot. So I got my private pilot's license in 2020. And so that's another area that was really exciting to me. So when Anders reached out and we started talking about the aircraft that Heart is building and the challenges to get that aircraft to market, and he talked about his vision for building an engineering hub in Los Angeles and adopting a more design-oriented philosophy when it came to designing the aircraft, more vertically integrated approach to developing the aircraft. That was really exciting to me and sort of matched up well with my experience. And, I think both of us, it was a really exciting idea to sort of build this team in LA and make the aircraft company of the 21st. What year are we? Make the aircraft company of the future.
And Andrew also comes from a technical background, so I'm curious, like, what is it like to be the CTO for a technology-minded founder and leader?
Well, I think technology-minded individuals make the best leaders. Obviously, SpaceX, Elon is very technology-minded, and I think that when you want to build a company like Heart that's competing in this industry, which is fundamentally about the engineering, about the technology, you want to have a leader who is forward-looking, who continues to drive innovation, continues to drive progress, and doesn't want the company to stagnate as a result of overemphasis on, cost or timeline. You have to be willing to take technical risks.
Right.
And so, Anders and I both see that very much the same way. And I think that he's, exactly the right person to be leading a company like Heart. So that's exciting. That's really exciting. His experience and his skill set is different than mine. So from a technical perspective, we sort of complement each other. I have the software, the systems, the electronics experience, and he has the aeronautical background. And, an aircraft is an incredibly complex machine. So you have to have all these skill sets, more and more. The electronics and if you're building an electric aircraft, the power systems are really key to the design of the aircraft.
When you think about kind of what's happening industry-wide, I mean, there's a lot of buzz, especially in the capital markets, around some of the electric kind of small personal vehicles. Like we've seen a lot of stories about, those startups. I'm curious how you would think about or talk about Heart's unique approach to aviation, to the aviation sector. Like, what is it about Heart that makes it the company we should focus on kind of in just the broad airplane space or electric vehicle space, kind of the confluence of those two things?
Yeah. Well, I think there's a lot of opportunity in aviation. So I don't think that there's one single winner when it comes to electrification. And obviously we follow and have relationships with some of the companies that are building, like you said, personal transportation vehicles. And I think that the work that's going on there is extremely exciting as well. The Heart aircraft, so it's a 30-seater. It's a regional aircraft. It's designed to compete in the market that turboprops would historically serve. And so this is the largest aircraft capable of fully electric flight. Our plan is to fly the X1 demonstrator next year. When that aircraft flies, it'll be the largest all-electric aircraft ever flown. And, as we move towards the ES-30, our production aircraft, when that flies, we expect it'll be the largest hybrid electric aircraft ever flown as well. And so our aircraft really fits in very directly with a segment of the market that airlines are currently serving.
Yep.
So there are currently aircraft approximately the same size as ours that are out there that are flying and that are running, scheduled routes. And so that's where we see that, this product really directly makes an impact on existing service. And the larger at this point in time, the larger the aircraft you build, the more challenging electrification becomes. So we think we're sort of at the top end of that. And obviously, as the technology improves, the battery technology improves, we hope that you'll see electric and hybrid electric aircraft serving a larger and larger segment of the market and going longer distance with more people.
You talk about kind of electric and hybrid electric. I'm curious if you kind of would give us a bit of a primer as to how the layperson could think about the technology, but also kind of the importance of having both those technologies in operation or right now and where we go in the future. Like, how do you kind of think about that journey?
Absolutely. So people are obviously very familiar with electric vehicles on the highway today. And, I think when you talk to most people, it's a common understanding that the battery in an electric vehicle on the highway is a really important part of the vehicle and also a big mass driver, right? So, you have a heavy battery that makes the car heavier. And if you want to have longer range, the battery has to be heavier. And, the reason for that is that the battery is about 40 times less dense than gasoline when it comes to energy density. So, to get the same amount of energy, you can have a battery that weighs 100 kilograms, or you can have fuel that weighs 2.5 kilograms. So there's this huge ratio between the energy density of battery and gasoline. An electric vehicle on the highway, relatively speaking, you don't need that much energy. So you can put a battery in a car and it doesn't really change the characteristics of the car that much, relatively speaking. In an aircraft, it's a huge difference. The fuel tanks in an aircraft normally represent a pretty high percentage of the weight of the aircraft. And when you go and you try and convert that to battery, you try and make it electric, the battery ends up weighing many times more than the aircraft originally weighed. And so obviously the wings need to get bigger and the fuselage, everything needs to get bigger. It's just very, very difficult to build that aircraft. So with the hard aircraft, we're really pushing up against the limits of what's possible with battery technology that is available today. And so our aircraft, the range of the aircraft, if you're just using the electric propulsion, is about 200 kilometers, which seems like not a very long distance for an aircraft, but for the kind of routes that you would fly with this kind of an aircraft, it actually is a pretty good match for how our customers will use it. But you can't go any higher than that with the batteries that exist today, or not very much. And so that's why we have a hybrid system. So we have the jet fuel powered turboprop engines on the wing as well. And what that means is that for most of the flights we would expect the airlines to fly using our aircraft, you can fly all electric. But if there's a contingency, you need to divert to another airport, or you want to move the aircraft between different locations that you're offering service, and so you need to fly a long distance to do that. It's called ferrying the aircraft. If you want to ferry the aircraft, you can use the hybrid system, you can use the jet fuel turbines, and you can fly up to 800 kilometers. So you really get the best of both worlds. You're making the most out of the batteries that you have and getting the longest range that you can out of that. But if you need to, you can use the hybrid system and you can fly further.
Would you indulge us and kind of nerd out a little bit on the ES-30 and tell us specifically about that plane and what you're excited about, and kind of keep going on the technology here?
Absolutely. Yeah. So the ES-30 is a hybrid electric, battery electric regional aircraft. So it's a 30-seater, 30 passenger seats, and then 2 pilots. And the aircraft, like I said, it will fly about 200 kilometers on all electric. And so that's electric from takeoff all the way to landing, which is cool because you get the electric takeoff, which is quieter than a comparable turboprop aircraft. And then in flight, it's also going to be a little bit quieter. And meanwhile, you have the hybrid system available so that if you want to extend the range, or, if there's a contingency scenario, you can switch over to that. So each of the electric motors on the aircraft is 1.6 megawatts. We have 3.2 megawatts of electric propulsive power on the aircraft. The battery in the aircraft weighs about 4 metric tons. So it's a very, very large battery. And we can charge that battery in as little as 30 minutes. So, really, really high performance electric power system in this aircraft. And also a really efficient aircraft structure as well. So it's an all composite structure. And so that's efficient both in terms of your mass as well as your construction process. So we have a high level of automation in the manufacturing process, which brings down the cost of the aircraft. And yeah.
You talk about kind of a lot of these routes, the ideal routes. And I know the company itself is based in Sweden, and there's a lot of short haul travel opportunities like in many parts of Europe. Curious kind of what the business case was to begin to shift to North America as a market, and kind of, you're obviously based in LA. So give us a little bit of explanation on that.
So there are not many turboprop aircraft flying in the US, in the continental US, serving scheduled routes. And the reason for that is because the economic, it's a highly, highly optimized industry. The airlines are pursuing lower ticket prices. If you adjust for inflation, the cost to fly on an aircraft today is lower than it has been, ever in the past 20 years. And so that's really good for the consumer in the sense that, it's easier for people to fly. It's lower cost for people to fly than it ever has been before. But it means that, in order to achieve this, that the airlines are very strategic about the routes they fly and cutting costs as low as possible on those routes. And one of the biggest costs with operating an aircraft is the maintenance cost that goes into the turbine. So if you're flying a jet, you're flying a turboprop, you have to do certain maintenance cycles on that turbine, and that ends up being quite expensive. So we believe with the Heart ES-30 that, because you're sort of taking advantage of this lower operating cost of an electric aircraft, you can serve routes that historically have not been profitable, and therefore connect people who don't have access to air travel today. There's, around 90% of the airports in the US today do not have scheduled service to them. So most of the air travel is centered on hubs. And then there's thousands of airports, regional airports, which don't have scheduled service and because it's expensive to add a route to those airports. And so if you're able to reduce the operating cost of your aircraft, you're able to improve the unit economics of flying those routes. We hope that this will enable airlines to serve airports that they haven't been.
I mean, it gets us back to, you've mentioned it a few times, but the mission statement of decarbonizing and democratizing air travel. Let's stick on this idea of democratizing a little bit, because I think that is a domestic kind of light version of it. But when we spoke previously, there's a ton of other really compelling examples. So I'm curious to hear kind of how you think about democratization and kind of the overall approach to why it's important to address it and why you guys have made that part of your mission statement, how you're achieving it.
Right. So as we talked about earlier, there's 6 billion people in the world who have not been on an aircraft before. And, many of those people live in parts of the world where air travel is starting to come online. People are building airports, starting to offer air service. And, this is a quality of life thing that is incredibly important to the human experience. When our ancestors, moved to the US, they were cut off from the rest of their family because the costs and the time commitment to travel back and forth was so incredibly high. And today we have this luxury of being able to fly from the US to Europe to visit family members and to see parts of the world that is, really incredible. And so as the rest of the world comes online, those people should have the ability to experience that as well, right? This is something that should be shared. But obviously the climate impact of doing that is already high, and as more and more of the world comes online is only going to get higher. So, both from a cost standpoint and from a carbon footprint standpoint, we think it's really important that there is a solution in aviation that allows people to travel long distances to meet relatives without the negative consequences that we face today.
Yeah. I mean, and just you think about like resource movement, right? Like the ability for supply chains to be more open, for goods and services to move in and out of places that may have restricted, the impact is just tremendous. I mean, when we think about the decarbonization side, then just to go back to that, I know sustainability is something acutely in focus for the aviation industry in general, even if it is only a sliver of the big picture. Like it's something that all the big carriers are working on, whether it's, with new types of sustainable fuel or, a lot of options. I guess give us a sense of how you think about sustainability for the aviation industry and the direction that the industry is moving and how you think electrification fits into that or solves for that or, its role in that bigger conversation.
So the industry has a goal of decarbonizing by 2050. And currently the trajectory the industry is on, it is not on a trajectory that will achieve that goal. And so there's a lot of work that needs to be done across the industry. Electrification is part of that problem. You mentioned SAF, sustainable aviation fuel. That's going to be a large part of the solution as well. Right now, the cost of SAF is high, both because the intrinsic process to manufacture SAF, as well as the demand, both of those contribute to the price being high. And so over time, the cost will come down, but it still ultimately will be a premium on air travel. So, we're optimistic about the future of SAF. We think that if you're flying short distances, then an all-electric system makes sense from the first principles perspective. It's the highest round-trip efficiency of any of these approaches to decarbonization. Right? So you can capture energy, using solar panels or renewables or nuclear, and then your round-trip efficiency from that point on is upwards of 90%. The batteries are efficient, the motors are efficient. Whereas if you're making green hydrogen or you're making SAF using a synthesis process, your round-trip efficiency on that process is going to be substantially lower than that. So if it's possible to fly electric, we think that that's the solution. If it isn't possible to fly electric because you're going, very long distances, batteries will not be capable of international transatlantic flight in the near future, at least. So that's the kind of flight where we think that using one of these alternative fuels really makes sense. So obviously we're excited about that aspect of decarbonization as well.
And I think you hinted at this as you talked about electrification and its role in the solution. A lot of folks we hear from who are related to electrification endeavors is, from a impact perspective, the energy is only as good as the supply of energy itself. And so I'm curious how you guys are thinking about the supply side to, make sure that that impact is maximized for the good, and how you think about and approach renewables and just the overall puzzle related to energy inputs.
Well, one of the nice things about electric propulsion is you somewhat decouple that. So most of our aircraft will be charged from the grid. And so, as you continue to reduce the carbon footprint of the grid, you directly improve the carbon footprint of any downstream consumer. So that's really exciting to us. One of the examples that I like to talk about is the use of these aircraft on island routes. So if you're in the Caribbean or you're somewhere flying between two islands, you can't drive, say the options are take a boat or to fly. And so from a time savings perspective, a relatively short distance, you can save a huge amount of time by flying over taking a boat. However, for locations like that, it's often quite difficult to get jet fuel in, right? So the cost of jet fuel ends up being higher. You're, moving it by ship. The carbon footprint of the transportation is high as well. And on the other hand, in many of these locations, your access to renewable electricity is quite good. You can put solar panels down for, pretty low cost, and you can get green and renewable electricity quite inexpensively. And so this is the kind of case where you get this outsized benefit of going to electric aviation, that the carbon footprint improves beyond just the switch to electric.
It also makes me think about kind of just the long term. These are deeply investment heavy industrial processes, workflows, supply chains, manufacturing. So give us a sense of kind of how are you guys thinking about the time horizon to market and to scalability?
Right. So we'll be doing a test flight next year with our Heart X1 demonstrator. We'll have another aircraft after that, the Heart X2, which is our second demonstrator, which will demonstrate hybrid flight. So we'll have the electric motors and the turbines on that and be able to show all phases of our flight envelope. And then after that, we will be refining our production aircraft and pursuing certification with the production aircraft. So we anticipate certification of that aircraft by the end of the decade. So our regional 30-seater hybrid electric aircraft entering service at the end of the decade. And this is the first iteration of our product. And then in the future, we expect battery technology will continue to improve. And so what's possible with this kind of an aircraft will grow. So, eventually there will be an all-electric version of this aircraft where the density is high enough that we don't need to carry the fuel and the turbines to get the range that we need for these contingency scenarios. So we'll have an all-electric version of the aircraft. And we think that you'll be able to build larger aircraft that are also hybrid electric. So, as you go from a 30-seater to a 50 or a 100-seater, and you start to build an aircraft that can serve a greater percentage of the routes people want to fly, and can do so while still achieving a reduction in your carbon emissions. And so a hybrid aircraft, you may not get to 0% carbon emissions, but you may be able to reduce the fuel consumption and the emissions by 20%, 30%, 40%. So really meaningful savings in the emissions on an aircraft that can fly, the 50th percentile route.
And we talk, I hear this and talk with folks a lot about this notion that especially when you think about, couple that with increasing demand for flight travel from, various parts of the world as we see growing development in many places that haven't had access to air travel. Like, it's important that we celebrate all the marginal victories and that kind of improvement on decarbonization in the next few years, while coupled with growing demand, actually moves us exponentially in the right direction. And like down the road, we're going to continue to want to improve, but like it's worth taking a moment and appreciating and celebrating that these incremental improvements are actually really important on a bridge towards ultimately, greater decarbonization across all sectors and all industries. But let's take a second and actually appreciate the huge impact that these marginal, impacts have.
Right. So aviation is one of the hardest sectors to decarbonize. Just incredible energy demands, flying close to the speed of sound, thousands of miles, just an incredible amount of energy that's consumed. And jet engines will only get us so far. And if you look at the incremental cost to improve a jet engine by, 0.1% efficiency, you're spending huge amounts of money and getting really marginal improvements. And so electrification, whether it's hybrid, whether it's all electric, this technology has the potential to give you double-digit percentage improvements or better,
Yeah.
as much as 100%, if you can do an all-electric flight. So this is really a huge impact in an industry that so far has been unassailable when it comes to making these big improvements.
Yeah. I mean, it might answer my next question, but I think, your partners and your cap table is filled with some of the brightest minds that are working towards solving some of these issues, like breakthrough, lower carbon. But even on the partner side, you've got the big airlines like United and Air Canada. I'm curious how those conversations have gone, and how are folks on both the capital market side and the aviation side, how are they thinking about your vision and your mission and the possibilities of electric aviation?
So you mentioned breakthrough and lower carbon. These are investors that are highly motivated by decarbonization and really only take on the parts of the problem that are the most difficult and the biggest challenges that we have. And so, highly motivated by the aviation challenge. And so both breakthrough and lower carbon have been, really great partners to us. And you also mentioned the airline interests. So we have an advisory board where we have participation from many, many airlines worldwide. We have airlines who are investors on our cap table. We have contingent purchase orders from airlines as well. So really strong interest from the airline community. And the airlines are looking for a solution. They're looking for ways to reduce their carbon footprint. They're looking for ways to reduce the operating cost, to make it possible to serve markets that they currently can't serve, that are not viable economically today. And so generally extremely strong interest and excitement from the airlines that we work with. And so we see this as primarily a technical challenge as opposed to a business challenge. So we need to deliver now.
Yeah.
We need to build the aircraft. We need to deliver it. And we think that the demand is only going to grow as we do that, because there's a strong commitment with the airlines that we're currently working with. They're taking a risk with this technology, with this aircraft. And so as we sort of demonstrate flight milestones and get to certification, certify this aircraft, we think the demand's only going to grow.
You're at the cutting edge of technology and engineering every day. And I suspect you have a lot of insight as to what else is out there that's exciting in climate tech, in clean energy, in what folks from Stanford engineering are doing now that's going to change the world for the better. I'm curious kind of if beyond the fact that I think, batteries are going to get lighter and better, and I think battery technology will leave us all impressed, by 2030 with what's next. What else is out there that you see that are big breakthroughs that are happening, or that you're excited about the potential of?
Well, something that's very personally exciting to me is the amount of interest in hardware today. So I think the amount of startups and investment into hardware development is higher than it has been for 20 years. And so the technology that is coming to market, not all of it is consumer facing. A lot of it is sort of behind the scenes industrial work. But the technology that's coming to market is really, pushing us forward in a very meaningful way that, maybe some of the software startups of the last 20 years have, not been as impactful.
Yeah.
So really excited about that. There's a manufacturing revolution going on in every industry right now. So companies like SpaceX, like Tesla, have sort of shown that the gains to be had through increased automation, both in terms of the actual manufacturing flow, but also in terms of the software that supports it. So more sophisticated MES systems. We've got additive manufacturing has been another sort of revolution that's starting to see its way into like actual products in a big way. The space industry has a lot of additive now. So these technologies, which are really a combination of the software and the hardware, have made it possible to manufacture complex systems for a much lower cost and to a higher performance than in the past. And so every industry is starting to be affected by that. So we've seen it in automotive, we've seen it in space, we're seeing it in aviation, but it's also affecting boat building and agriculture and all these other industries. You've seen the downstream impacts. So there's companies that came out of SpaceX. There's companies like First Resonance, Epsilon 3, SIFT, which are sort of taking that software first approach to manufacturing and really adding efficiencies there. Another company that I think is really exciting is Freeform, which is building a more advanced 3D printing technology for metallic structures that can be certified for aviation and other challenging industries. So really cool technology there. A lot of companies working on reshoring battery manufacturing. Right. So not just the technology innovations in the battery chemistry itself, but also manufacturing it domestically, which improves the supply chain, the carbon footprint of the supply chain, and companies like Redwood Materials, and looking at recycling batteries, and obviously that has a huge impact environmentally, a huge advantage there. Companies that are looking at some of the most challenging. So we talked about aviation being really challenging from a decarbonization standpoint. There are other industries like agriculture, concrete production, steel production, which are incredibly challenging for a different reason, right? It's not about how you store the energy. It's about the sheer amount of, hydrogen or other hydrocarbon products that you need in order to actually run the process. And so you've got companies like Electric Hydrogen that's coming up with solutions for that. So I think it's a really exciting time to be building hardware. And I think that, my personal bias, building hardware is more exciting than, pure consumer software. And so I'm sure I'll get some downvotes from your audience for that. But I think this is a really exciting time to be an engineer.
Yeah. Last question. I mean, you mentioned a lot of technologies and companies that are in the process of potentially making a positive impact over the long term. And yet we see a lot of headlines every day that make it feel, challenging, to say the least, right? I'm sure we'll have a host of headlines. We're recording this on Monday of Climate Week, and so there'll be a lot of headlines of reports coming out this week that demonstrate that we've got a lot to do still, and a lot of challenges on the decarbonization front, on the sustainability front. With all that negativity, and especially in an industry that it takes time and investment and a lot of effort to get that sliver of positive impact. How do you defeat that kind of negativity? How do you defeat the defeatism? How do you put the blinders on and stay focused on the positive impact you could possibly make?
Well, I think that there's a lot of engineers out there. There's a lot of, particularly young engineers, but all ages, who are really motivated by decarbonization. Most people we speak with, most engineers we speak with, are excited about that element of the mission. And all over the country too. This is not, just because we live in LA. Yeah. There's a lot of excitement for that. And I think it's partially because of the decarbonization, and also partially because it's a catalyst to drive the technology forward in a fundamental way as well. An electric aircraft is going to be a better aircraft than a jet fuel powered aircraft once we're able to achieve that, because it's going to be quieter, it's going to be cleaner, it's going to be more comfortable to ride on, and in some ways it will be higher performance as well, and over time it will ultimately be high performance. So people are really excited about the technology, and I think that the negativity that we see in the media is really more a function of just how incredibly challenging this problem is to solve.
Sure.
The industrialized world consumes vast amounts of energy, and decarbonizing that entire supply chain is just incredibly difficult. And that's a challenge for us as engineers. Obviously, politics has an impact. If we have the political will as a country to invest in green technologies and invest in renewing our industries and industrialization projects, that helps push us forward. But the technology needs to be ready for us to do that. And so that's, I think, actually a really good combination. We have engineers who are really excited about the hard technical work that needs to be done. And then we have market dynamics, which are poised and sort of ready to accept these technologies once they're ready for the mainstream. So, motivation is not, I think, a challenge. Obviously, we're not moving quickly enough yet to hit our goals. That's the problem. Sure. So we need more great engineers, and we need, politicians who want to invest in America and in the world, and take on these big projects, which are going to cost money today, but also create jobs and set ourselves up to have better infrastructure in the future. We need those things. But I find it very motivational to be working on this kind of technology with teams of people who are really excited about it as well.
Thanks so much for taking the time. Where can folks connect with you or learn more? Where do you want to send folks who want to continue reading or learning?
So our website, heartaerospace.com, has a lot of information about the project and the team. We're hiring in LA, we're hiring in Sweden, in Gothenburg. So, people who are excited and want to build electric aircraft, we're always on the lookout for really great talent. And that's
perfect.
That's what I got. Yeah.
We'll throw everything in the show notes for folks. Thanks again so much for taking the time today. A lot of fun, and we're excited to watch as Heart's journey continues. So thanks, Ben.
Well, thank you so much. This has been great.
Huge thanks to Ben Stabler for joining us on Consensus in Conversation this week. You can find out more about Heart Aerospace at their website, heartaerospace.com. We'll have all the links for that and to connect with them on socials in the show notes. And as a reminder, we'll be taking off next week. We'll be back with our regular schedule on October 17th. As always, you can email us at cic@consensus-digital.com. That's cic@consensus-digital.com. You can also message me directly on LinkedIn and Threads at ckgaughan. That's at ckgaughan. Send us your questions, comments, ideas for future guests. We love getting your feedback. If you enjoyed this episode, please take a second to leave us a rating and review on Apple Podcasts. It's so helpful with growing our reach and adding new people to the conversation. And it helps us to continue bringing you more awesome talks with the business leaders you want to hear from. All right, we'll catch you back on October 17th. Consensus in Conversation is hosted by me, Conor Gaughan, and executive produced by me and Jeff Rock. Our producer is Will Gatchell, with editing by the team at Reasonable Volume. Special thanks to the Consensus team, including creative director Kate Tucker and Greg Harrigal on research. Consensus in Conversation is a podcast by Consensus Digital Media, produced in association with Reasonable Volume.